we're going to learn how to classify numbers. Friday, we learned only the difference between rational and irrational. And the bottom line is if you can guess the next number, it's a rational number. If you can't guess the next number in a number with a decimal, it's irrational. Get your calculators out. Always have them out. If you don't have a calculator, you need to start being a little worried. Like, am I going to check one out of the library, or am I going to buy my own personal calculator? Because at some point in time, I'm going to have to call it and say, you cannot have your phone out in class. All right, here we go. 3.87, thumbs up if it's rational, thumbs down if it's irrational. Go. Can you guess the next number? What? There is no number, so that means it is rational. All right. 1/3. If you don't know, do it on your calculator. 1 divided by 3. Thumbs up or thumbs down? Go. Perfect. It is rational because what is the next number? 3. All right. Square root of 5. Oh, I didn't get my calculator. I didn't get my TI-84 ready. Drats. What's the square root of 85? Thank you. I mean, not the square root of 85, but the square root of 5. Okay, thumbs up if it's rational, thumbs down if it's irrational. Perfecto. All right. 2, repeating. Thumbs up if it's rational, thumbs down if it's irrational. Perfecto. All right, we're going to move on. Here's all the answers. Now, that was just a review. Okay, so now we're going to take our numbers, rational and irrational, and we're going to classify them even further. So you have a foldable. I want you to fold it. And when we're done today, you're just going to glue it right here. But don't do it right now, because sometimes I think y'all find it easier to write in when you can turn it. Okay, we're going to start with you. Somewhere you need to write real numbers. Oops, I folded yours so wrong. Actually, it totally doesn't matter. Okay, so if you fold it and you have this in the front, open it up. Right here, you don't have a place to put real numbers, so I want you to write real numbers right here. Or if you want to, you can write the definition I'm about to give you right here. Totally doesn't matter, wherever you feel comfortable doing that. Real numbers. So easy. Rational and irrational are real numbers. Here, everything that you and I talk about in 8th grade math, Floyd, you should be writing this down, babe, is a real number. You don't know anything that is not a real number right now. I think I told y'all the other day, or maybe that was 7th period, if it's not a real number, it's an imaginary number. We're not talking about imaginary numbers. If you want to know what one is, come see me and I'll show you. But right now, rational and irrational are real numbers. Okay, another number, kind of number, is a natural number. And they're all positive numbers. Positive. So by natural on the bottom, you just want to put positive numbers, and then you want to write 1, 2, 3, etc. outside there. Positive numbers. So positive numbers are called natural numbers, and you can write that right there where it says natural numbers. So you know what natural numbers are. So you can write it right here at the bottom where it says natural numbers. I'm going from the bottom up on your foldable. Or you can put it somewhere else that you feel like you want to put it. I like to tell kids that natural numbers are what kindergartners. If you tell a kindergartner to start counting, they're going to go 1, 2, 3, 4, 5. What number do they skip generally? 0. A 0 belongs in the whole number category. It's all the natural numbers plus 0. There is no difference between whole and natural numbers except for 0. All right. So you can just put the whole number, the natural numbers plus 0. And then the next category are integers. And integers are also whole numbers and their opposites. Whole numbers and their opposites. So if it's got a negative sign and it's a whole number, it is also an integer. So it's 1, 2, 3, negative 1, 2, 3, 0. Those are examples of integers. And then I've saved the 2 that we've already done for last. Who in here can tell me what a rational number is? Any number that can be written as a chi. Any number that can be written as a fraction. Yes. Any number. And you don't even have to write all that. You can just say any number that can be written as a fraction. Any number that can be written as a fraction is a rational number. And so then, by converse then, the definition of irrational number is a number that can't be written as a fraction. You don't have to write all that. You can just say can't be written as a fraction. Can't be written as a fraction. Or, if it's a decimal, you can't guess the next number. You can't know for sure what the next number is going to be. That's an irrational number. The most famous irrational number of all? Pi. Okay, whoops. Okay, so now we're just going to learn to classify the numbers into sets. So now you have this on the front. And we're going to put numbers. This is a diagram, and we're going to put numbers in this diagram so that you know the best description of the number. So we're going to start with the natural numbers are all the kindergartner counting numbers. So I'm going to start with the easiest one, 2. If you put a number here, it is also, a 2 is natural. It's also a whole number. Is 2 a whole number?
Yes.
Yes. Is 2 an integer? Integers, positives, and negatives. Yes. Can you make 2 a rational number? Yes. So a 2, the best description of 2 is a natural number, but it is also natural, whole, integer, rational, and all of these numbers are real numbers. You might want to write that. All of these are real. Real numbers are irrational and rational. So a 2 is natural, whole, integer, rational, real. If you put it in this category, it is all of these except for irrational. That's why this right here is a straight line and not in this circle. All right. Another one is, what's the square root of 36? It's 6. So it may not look like this, but sometimes you might have to do a little math. So it's natural, whole, integer, rational, and real. So those are examples of natural numbers. 13 is a natural number. Just random whole numbers. They're natural. Yes. Any whole number besides 0 is a natural number. So that's why up here we're going to put 0 right there. And 0, is 0 a natural number? But it is an integer and a rational and a real number as well. So we could put the square root of 25 here, except it also could go back down here, so we're really not going to do that. Okay, let's talk about integers. If you look at your definition, integers are positive and negatives, but they're still whole. So, negative 18, negative 99, negative square root of 81. And so these are also integer, rational, and real numbers. Negative 18 is an integer, rational, and real. So when you're naming a number, you go all the way up, all the way up, all the way up on your chart, and when you hit that black line, zip, you do a left turn. Rational numbers are any number that can be written as a fraction. 1/3, 0.875, 3/4, 0.2, repeating, even repeating. If you can figure out, if it's in decimal form and you can figure out what the next number is, it is rational. All right, and guess what? Rational numbers are real numbers. Okay, and then irrational. Give me an irrational number that you know. Okay, in all the work that you've done in the last couple of days, can you name another irrational number? It's not 2 squared, but it's the square root of 2. Yes, the square root of 2. And so those names are rational and real. Rational and real. Okay, so one of the things I want to emphasize is this natural, whole, integer, rational, real are all the names for 2. But the best name for 2, Ruben, is natural. 0 is whole, integer, rational, real, but the best name for 0 is -18 is integer, rational, real. But the best name for -18 is integer. Yes? Yes? Or you could say that's the smallest category. Okay. We're not doing this. We're not doing that. I just went over all this. Okay. Get your whiteboards out. What time's the bell ring? 3:17. I know that. Okay. T for true, F for false. Are you ready? And this is what you're going to look at. You're going to look at the front of your foldable to see this. Every real number is a rational number. Don't hold them up just yet. Every real number is rational. T for true, F for false. Hold your boards up. Let me see what you got. Hold your boards up. If you're getting it wrong, I don't care. I just want to know. All right. Guess what? That is false. Name me a real number that is not a rational number. Pi. Yes, if it's irrational. Very good. Okay. Number 2. Irrational numbers are not real numbers. T for true, F for false. Irrational numbers are not real numbers. T for true, F for false. Hold up your boards. Let me see what you got. You should have a big fat F for that. Yes. Irrational numbers are real numbers. Every number that I can possibly tell you is a real number, no matter what. I have never told you an imaginary number yet. Okay. Every integer is a rational number. Every integer, if I write it here, because this is the same thing, if I write it here, is it also in here? If I write it right here, if I write it in the I circle, is it also in the R circle? T for true, F for false. If I write it in the I circle, is it in the R circle? Hold your boards up. Let me see what you got. That is true. That is true. If I write it right here, it's also in this big circle right here. Okay. Number 4, I can't even see what it says. Some whole numbers are irrational numbers. Some numbers that are here are also here. Some numbers that are here are also here. Hold your boards up. I didn't give you all time. T for true, F for false. Some numbers that are in this whole number circle are also in the irrational circle. That is false. That's not going to happen. Is that the last one? All right, last but not least. some rational numbers are not integers. Some numbers that are right here are not down here. Some numbers that are here are not here. T for true, F for false, hold your boards up. That's going to be true. If I write it up here, that doesn't mean it's down here. Oh, we got another one. All right, every rational number, every number here in this circle anywhere is a real number. T for true, F for false. Every number here is a real number. Hold your boards up. Big T. All right. Every whole number is an integer. If I write it right here, it is also in this circle. If I write it right here, it's also in here. Every whole number is an integer. Hold your boards up. Yes, good job. That's T for true. Super job. All right. All right. How can I do this? Okay. Think about this. If I were going to describe the number of people in this room that are wearing glasses, which basically, oh, you know what? All right. How many people are wearing glasses in here? 2. I'm not technically wearing, but let's just do it like this. Nope, I can't see y'all. All right. How many glasses do I have in my head? How many people in this room are wearing glasses? 3. Where would 3 go on here? Natural. So natural, whole, integer, rational. It goes all. Which one's the best? Natural. So identify the set of numbers that describes each situation. You would put natural, or you could put whole, because it's a whole number. Okay, what about this? Whoa. The circumference of a flying disc has a diameter of 8, 9, 10, 11, or 14 inches. So in other words, when you're trying to find the circumference of a circle, where would that go? If it's irrational, since you said it out loud, I'll say this. If it's irrational, that means that the circumference of a circle never stops. Does it stop? Yes, but can it be anything? So the best number to describe it would be this, because can you have a decimal? Yes, okay, so the best number to describe it would be rational. Except the circumference of a flying dish has a diameter of, I would disagree with that. Moving on. The amount of water in a glass as it evaporates. When you measure that, when you measure the amount of water in a glass, does it always have to be in whole number increments? Could it have decimal increments? Then what's the answer to this? Rational. Whoa. The number of seconds remaining when a song is playing, displayed as a negative number. So, it starts out with, all right, there's like -3 minutes left, then -2 minutes left, until you count down, and at 0, the song's over. So where would that go? Can you have a decimal in a second? Yes, so where would that go? Rational. Okay. All right, listen up. This is what we're going to do. How many kids are I having in this class? 3, 6, 9, 12, 15, 18, 19, 20, 22, 24, 25. I want 5 groups. There's 25 people in here? Yes, boom, 5 groups of 5. So I'm going to put you in teams. 1, 2, 3, 4, 5. You're a team. 1, 2, 3, 4. Boom, you're welcome. 5. You'll have a prom date. 1, 2, 3, 4, 5. Yes? You're welcome. Except you're my only other girl, Colleen. Chris, I'll switch. What group? Oh, just kidding. Okay, so 1, 2. Yeah, I can't do that to you. Chris, what group did I put you in? No, you're welcome. Look at all the prom date opportunities you got coming your way. All right, so EJ, sorry, and Colleen, yes, that's 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5. Line up somewhere with your team. Hey. Hey. I'm gonna have a birthday. I know it's our. You know what? I guess I probably maybe should stop the recording. I'm gonna have a birthday by the time you get in your lines. I'm gonna go ahead and stop the recording so your parents don't have to hear me yell at you.